Hello, everybody. Welcome to lesson 27 called Angles and Polygon Angle Theorems. So again, remember, a theorem is a rule. So a theorem is just something that we need to learn is true and is always true and work with it. So we're going to learn some theorems, some rules about angles. Let's take a look at some angles. So during this lesson, I want us to just I want you to bear with me. There's going to be quite a few theorems listed here, but once you get the hang of using these formulas, it's pretty quick to use. Theorem 1, angles on a straight line. Angles on a straight line equal 180 degrees. That's the rule. Underneath, you see some examples here. Complementary angles add to 90. So this L here will equal 90. The total will be 90. So knowing that rule, it's just a matter of subtraction. We know this is 40 minus that gives us x, and we know x is 50. So opposite angles are equal. A over here is 70 because the opposite angle is 70. And B is 110 because the opposite angle is 110. So if ever you see any angle situation that looks like this, set up in this manner, you know you can use that theorem. You know that the opposite angles will be equal. And supplementary angles add to 180. So we see here, we have a flat line. We have a flat straight line. We know this line is 180 degrees. So to find this x minus the 50, we know x here would be 130 degrees. We found that out because we knew our theorem of x of 180 degrees being that straight line. Now, here's other patterns. We have a Z pattern, an F pattern, and a C pattern. This is our Z, our F, and our C. So here are our rules. The angles set up in a Z pattern, those will be equal. The angles set up in this F pattern will be B, those are equal. Angles set up in this C pattern, the inside, those two angles, C and D, will equal 180 degrees. These patterns will make more sense when we start to use them in our practice questions. Interior angles of a polygon. So what is a polygon? A polygon is a shape with straight sides. That's it. A polygon is a shape with straight sides. Now, examples there are listed: triangle, square, pentagon. I'm sure you could think of many. Triangles have specific rules for their angles, and some of them we've worked with already. The sum of the interior angles of a triangle are 180 degrees. The sum of the exterior angles, so we have exterior angles here. These were interior. Now we're looking at the exterior, which means outside. The angles outside of the triangle are 360 degrees. And if we're trying to look for a singular exterior, if we're trying to look for one angle outside of a triangle, that is this rule here. So again, this is simply just, it's like a formula sheet. It's just giving us the rules. It's giving us the theorem so that later when we're doing some practice questions, we can refer back to this. Same with these here. We have some formulas that we need to know. If it's asking us for the sum, the total, so that's something to remember. Sum is another word to say total. Sum of the interior angles in a polygon. The total of the interior angles in a polygon. That is this formula. N is the number of sides in the polygon. N is the number of sides. That is important for us to remember. The next formula is going to be talking about, or the next theorem, sorry, sum total of exterior angles, outside angles of a polygon. The rule is that the exterior angles is always 360. And now for a polygon with all equal sides, if it's asking for each interior angle, that is this formula. For this formula to work, very important that the polygon has to have all equal sides though. And that'll find you the individual angles, each angle in the polygon. Now time to apply our theorem. So if you notice here, we have straight lines, we have some shape patterns happening, we have a 90 degree. So you're going to use the sheets we just read through. You're going to find on those sheets what applies to these questions and use the formulas, use the patterns to just plug in the numbers to find our answers. Here we know this is a straight line, straight flat line. We know all angles on a straight flat line equal 180 degrees. To find x, we're going to do 180 minus 34. And that will give us 146. Here we have opposite angles. So if this is 81 degrees, then we know B is 81 degrees. That's an opposite angle. Now to find A, we know A and B are on a flat line. The A and B should equal 180 degrees. So let's, A will be 180, take away 81. And that gives us 99 degrees. So we know A is 99 degrees. Now, A and C are opposite angles. So we know C is 99 degrees. So you're noticing we're using the patterns, we're using the formulas and the theorems that we ran through to now put it into practice on these questions. This here is a 90 degree. That little box there in the corner, that's telling us it's 90 degrees. So that's telling us it's 90 degrees. To find x, we will have to do 90, take away 68. So x is 22 degrees. Here you'll notice we have a Z pattern happening. So actually, you know what? We're going to start with the C pattern first. We want to find what is this. So we remember the C pattern looking back. The C pattern, these two should equal 180 degrees. So question mark equals 180 degrees, take away 130. So that is, so this is 50. 50 degrees. Now, to find x, we know it's on a flat line with this 50. X will be 180 minus this 50. Because this 50 is on a flat line with x, we know that flat line will be a 180. So because we had to do multiple calculations here, to keep our work organized, we can put a little note up here. Therefore, x is 130 degrees, just to be clear. This is our F pattern. So we know from our F pattern that they are the same. Again, our C pattern, we know that should equal 180 degrees. So 180 minus 65, this is 115. Down here, we will have to do a couple calculations to find these letters. It's asking us for X, Y, and Z. So starting off with X, we know it's on a flat line, a straight line with 55. That straight line is 180. We can find X knowing that. X, 180 minus 55 is 125 degrees. So this will be 125 degrees. Now, knowing this, we have our F pattern. So we know Z is the same, 125 degrees. Now with Y, we know Y is on the same line as Z. So that's on a straight line together. We know that should be 180 in total. So Y will be 180 minus 125, which equals 55 degrees. So Y equals 55 degrees. So if we wanted to do a summary, therefore, X is 125 degrees, Y is 55 degrees, and Z is 125 degrees. Triangles. Now, okay. This is looking for our interior angles. So we know the inside of this triangle should be 180 degrees. X. So we're going to subtract the two angles we're given to find X. (180 minus 42 minus 65 is 73 degrees. This is what I was saying before. This is looking for an exterior angle. So it's on a flat line with this angle over here. So if we find this angle inside the triangle, we can find the one on the outside. So let's call this Y. Y is 180. 180. Take away 80, take away 70. That gives us 30. So we know y is 30. Now we can do x because we know x is 180 minus y. So this over here will be 150 degrees. This is looking for an exterior angle. Our theorem from before is exterior angles all equal 360. So knowing that theorem, we can use subtraction to find our missing angle. So they all should be 360. Let's take away the ones we have to find what our last one should be. So I did 360 minus this 140 minus that 135 to give us what should x be? X should be 85 degrees. This is asking us for this inside triangle. Now, if we look back to our theorem sheets, this is what it's asking us to use. And if we label based on our sheets, this is what we will find. Now, C is 110, 40 plus B, 110. We'll bring that 4 to the other side of the equal sign, which will make a negative. So B is 70. Now this is asking us for the inside angle x at the top there. The first thing we have to do is find these angles on the other side inside the triangle. And then we can add those two, subtract it from 180 because we know 180 should be in there, and that will give us x. So let's label this y and z. So let's start with y. Again, these are on straight flat lines together, both of these. So we're going to be using 180 to find the other sides. Y, 180 minus 150. So this is 30. And z, 110. Okay, now that we found those two angles, we can find the top one by doing 180 minus the 30 minus the 70, and that will give us what x should be. And that will give us 80 degrees. Now, if we add 80 plus 30 plus 70, it should equal 180 degrees. Let's try that. 180. No, not 180. Sorry. 80 plus 30 plus 70 is 180. That's just double checking our work to see if we got the right angles. Now, now we're going to be speaking about polygons. Polygons where you're finding the sum of the interior angles. So going back to our theorem sheet, we have those formulas. I'm going to write them at the top here, just so we don't have to flip back. So this is the formula we needed to use. N is the number of sides. Okay, now we have all the rules. How many sides does this have? 1, 2, 3, 4, 5. 5 sides. So we can do 5, take away 2, times 180. So that would be 3. So we know the sum of the interior angles of this polygon is 540. The total number, if we add all those interior angles together in this polygon, is 540. B will be the same. Okay, so I'm going to leave that for you to practice. Okay. Number 4, find the sum of the interior angles with the polygon for 11 sides. So it's just giving us the sides amount, but that's okay because that's all we need to find the answer. N, which is 11, right? N is 11. 11. Okay. 11 is 9. 9 times 180 is 1,620. So the sum equals degrees. Here it's asking to find x. So we know n is 4. This shape has 4 sides. So first, let's find the total of what all these angles should equal. So let's find our sum. What should it be? Using our formula. All right. So we know the total in this shape should be 360. So now to find x, we can do 360 and we'll minus the ones we already have. Take away 90, take away 65, take away 95. And that will give us our answer. So x will be 110. So we could do therefore 110. Find the measure of each interior angle. So n is 8. This shape has 8 sides. Now, all the sides are the same length. That's what these little lines are showing us, that they're all the same. So when we go back to our theorems, we can use that formula to find each interior angle formula. So that is n, but divided by n. Okay, so n is 8 divided by 8. Okay, so we will find this. So we're going to say, therefore, each interior angle is degrees. And now there's some word problems. The measure of 3 interior angles of a quadrilateral are 68, 29, and 103. Find the measure of the 4th interior angle for the quadrilateral? The quadrilateral has 4 sides, so we know that tells us our n. It wants the 4th interior angle. We have 3 of them. So now we know we can find the sum of all of them minus the ones we already have to find that 4th one. So let's find the sum. Or take away 2 is 2. So the sum of all of them should be 360. Now we will take away the ones we have to find that 4th interior angle. So let's call that 4th interior angle x. All right. X, take away the 68, take away 29, take away 103. Those I got from our question. So now we can write, therefore, 4th angle is 160 degrees. The last word problem is asking us for the exterior angles. The measure of the exterior angles at 3 vertices, 3 corners of a quadrilateral are 75. So if we draw quadrilateral somehow, okay, I draw it better. All right. Okay. We have 75, we have 125, and we have 35. It's asking us, what is this? So we know all exterior angles equal 360 degrees. So all of those added together should be 360 degrees. So 360 degrees, take away equals our question mark. So our question mark is 125 degrees. Okay. And that brings us to the end of our lesson. I know that was a lot to absorb, but if you need to go rewind and rework through one of the questions, practice with your student handout, and good luck.